Okay, so we're starting a new unit now. We're going to take a look at circles. This should be fairly easy. Beginning lesson, nothing major, but please make sure that you do become familiar with the vocab that you're going to need to complete the unit. All right, so first off the bat is we've got the basics. So any segment with both endpoints on the circle, so you see how we have this segment here, so I'll just highlight this segment. So we have this segment here, and the endpoints are on the circle. Okay, so we have this. This is known as a chord. All right, this is a chord. C-H-O-R-D. This is a chord. Then we have any segment with endpoints that are the center and a point on the circle. So now we're going from the center to the point on the circle. This is your radius. The center of the circle. A circle is usually named by the center point. So if this is the center, then this would be known as circle A, because it's named by the center. And then a chord that passes through the center. So notice it's got the endpoints on the edge, just like the chord does. But this one goes through the center. This is your diameter. So those are your basic parts. There'll be more later, but those are the basics. So now identify the parts of this circle over here. So if we're going to name this circle, the center is here. So this would be circle Q. So I would use the symbol for a circle, and I would say circle Q. Name all the radius. So QP, so QP, QT, and QS. What is the length of any radius? Well, since this one's 16, they're all 16, so 16 meters. And what would be the length of any diameter? Well, remember the diameter goes all the way through, so if this is 16 and this is 16, then you would have 16 plus 16, which is 32 meters. Okay, so if we're going to find the radius and the diameter, given some information here, it says finding the radius and the diameter, calculate the radius. Okay, well, first of all, I know that the diameter is 2 times the radius, and I know that the radius is half the diameter. So depending on what they give you will depend on which one of these formulas you're going to use. So if they give you the radius, so if they give me the radius, then I can plug it in right here. So the diameter would be 2 times 27. So the diameter would be 54. So the diameter is 54. This one, since they've given me the diameter, then I can say that the radius is half the diameter, and half of 18 is 9. So the radius would be 9. So just depending on what they give you, depends on which formula you want to use. All right, so finding the measures of intersecting circles. So notice you've got these 3 circles, and they all intersect. They all have their own diameter, and they all have their own radius. So what I'm going to do here is I'm going to use red for the big circle. I'm going to use this blue for the middle circle, and I will use green for this end circle. So that will be going through there. All right, so now I know that it says in the circle, in the diameters of circle X, Y, and S, that should be Z, so that should be circle Z, are 22, 16, and 10 respectively. That means that circle X is listed first and 22 is listed first. So the big red circle, it has a diameter of 22. So if it's 22, then that means this piece is 11 and the red piece is 11. Okay? So EX is 11, and it's an F right there. And let me erase a little bit of that right there. Okay? So EX and XY is also 11. Then circle Y is listed next, and it's 16. So circle Y, which would be the blue one, so that means this piece here, XY. If the whole thing is 16, then this piece is 8. And from Y to Z is 8. And then the last one is Z. So the green is 10, so that means ZG is 5, and ZF is also 5. So we've got these overlapping circles. So they want me to find EZ, which would be from here to here. So I want to find how far it is from there to there. Well, I know from E to Z, so you think about it, you've got EX plus XY plus YF and FZ. So you've got those 4 pieces. So I know EX is 11. I know from X to Y is 8. From Y to F, this little piece here is going to be 3. Because if the whole thing is 11, and then this piece is 8, then the leftover piece is going to be 3. And then from F to Z is 5, because it's half. So I just add it all together, and I get 11 plus 8 is 19. 19 and 3 is 22. 22 and 5 is 27. So your answer would be 27 millimeters. So you just have to break it apart. Another way to look at it, we could go at it like this. I say I know this is 11. I know that this is 5. I know this is 5. And then if you think about it, they told us that from here to here, they told us that's going to be 8 because they told us it was 16. So that's how I know that piece right there is 3. And then from here to here is also going to be 8 because it's part of the middle. So that's how you could add it all the way across also. All right, now if we're going to find, because you know once you have your radius or your diameter, depending on which one of these you have, you can find your circumference in your area. Because if you have the radius, you can find circumference. If you know the diameter, you can find the circumference. So if you know the diameter, you can get the radius, and you can find the area. So here we have a square, and we have a circle inside. So that means from this side all the way across is 9. So that means my diameter is 9. Well, if my diameter is 9, I can use this formula to find circumference. So I would say 9 times pi, and I'm going to leave it in terms of pi, so it would just be 9 pi meters, and that would be your answer. So this is in terms of pi. And then to get your area, of course, we would say pi radius squared. Well, if my diameter is 9, then the radius is half, well, that would be 4.5. So I would plug in 4.5. So then I would just need to square that. So 4.5 squared is 20.25. So 20.25 pi, and this would be meters squared to make sure that we have our units. So this would be your area. And that's all you have to do. It's very, very simple. All right, so here we go. Let's try one on our own. So it says, if the area of a circle is 432, so they're talking about the area of the circle. So I'm going to write the formula. The area of a circle is pi r squared. And they're telling me that the area is 432. So the big A is 432. So 432 is pi r squared. Well, since pi is really 3.14, so pi is really 3.14, I'm going to divide both sides by pi so I can cancel it out. So I'm going to divide this side by pi. So 432 divided by pi, and use the pi button on your calculator. And I get 137.51 is equal to r squared. And the opposite of squaring is to take the square root. So I'm going to take the square root. So now I'm going to take the square root of my answer, and I get that my radius is about 11.7, and it says to estimate, so you're not going to be exact, and since this is feet squared, then my radius is going to be in feet. So 11.7 feet is the estimate of my radius. Now this one says if the circumference is, so circumference, so for circumference I'm going to go pi d, because that one is easier. So pi d, and that is a d even though it doesn't look like it. So if the circumference is 50.94, then I'm going to replace the c with 50.94. So 50.94. So circumference is pi times diameter. Now again, I'm going to divide by pi so I can cancel it out. So I'm going to divide this side by pi. 50.94 divided by pi, and I'm using the pi button. I get 16.21 is my diameter. So my diameter is 16.21, and this is in centimeters. And then if you just take half, so if you do half of 16.21, so divide the answer by 2, I get 8.11 for my radius. And that's also in centimeters. So working backwards. All right, and last part says find the circumference and the area. Leave your answer in terms of pi. In terms of pi means pi will be part of your answer. So the circumference formula is pi d. So pi times the diameter, and I don't know the diameter because that would be across here. But what I do know is that this is a right angle, and I have, oh goodness, what do we have? Well, we have a triangle. Because you've got this here. Oh goodness, what is that? This is what I want. So you've got the diameter, and then you've got this chord, and then you've got this chord, and they make a right triangle. So I'm just going to do Pythagorean theorem real fast, and I'm going to add them together. So 16 squared plus 30 squared. So 16 squared plus 30 squared is 1156. And then I'm going to take the square root of that. And I get 34. So I get 34. So I get my diameter is 34. So the diameter is 34. So my circumference is 34 pi. Well, if my diameter is 34, then the radius is half, which would be 17. So this would be pi 17 squared. So 17 squared is 289. So area would be 289 pi. And you would be done. All right, last one. We have the circle inside of the square again. So if this chord is 7, then this chord is 7. Well, remember in a square, if you draw the diagonal, you get a 45, 45, 90. So if this is 7 and this is 7, then that means my diameter is 7 square root of 2, because you have that rule, x square root of 2. So that means my circumference is 7. Here we'll start with the formula. So pi d. So pi times the diameter, 7 square root of 2. So what I would do here is I would go, okay, 7 times pi is 7 pi, and then I still have the square root of 2. So my circumference is 7 pi square root of 2. And I would leave it just like that because it said to leave it in terms of pi. Now the area is pi r squared. So if my diameter is 7 square root of 2, then my radius is half of that. So that would be 7 square root of 2 over 2. I'm going to leave it as a fraction because it's going to be easier that way instead of having a decimal. So I'm going to go over here and I've got pi. My radius is 7 square root of 2 over 2, and I have to square it. Okay, this one looks a little messy, but it's really not. So I'm going to go ahead and bring down the pi because I can do that. So I'm going to square the 7. So 7 squared is 49, and I have a fraction. The square root of 2 squared is 2. and then this 2 squared is 4. So now I've got 49 times 2, so now I've got pi. 49 times 2 is 98 over 4. So now I'm going to do 98 divided by 4, and I get 24.5. So 24.5 pi. So that would be the area of the circle. And that's all there is to it.